In this question, let's solve Leetcode 875 Koko eating bananas. So over here it says Koko loves to eat bananas and there are n piles of bananas, and in the pile the number of bananas is given by piles at index I. Okay, so this would be an array which is given to us, which is what you can see in the example over here as well. Alright, then it goes on to say that the guards have gone and will come back in h hours. So Koko has a total of h hours to eat bananas. Okay, so she can decide how many bananas she would be eating every hour, and finally we would have to identify the minimum integer value of k such that she can eat all the bananas within the h hours when the guards are away. So that's the question at hand. So notice over here that we have to return an integer answer and we have to return the minimum possible value for k such that she can eat all the bananas in h hours. There's one more interesting thing over here. It's mentioned that each hour she chooses some pile of bananas and eats k bananas from that pile. If the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. So if there are banana piles like this, okay, so let's say in one particular hour she has completed these many bananas only. Okay, in the next hour she would do the remaining over here, and then let's say there are fewer bananas left than what she can eat in an hour. In that case she would not move to another pile. So that is what is given over here. So within each hour she will stay with the pile that she has chosen. So this is the question at hand. So basically Koko has to decide the speed at which she will be eating bananas, and because she likes to eat slowly, will have to identify the minimum integer value for k such that she can eat all the bananas within h hours. And there is also a constraint mentioned over here that in 1 hour she would stick with the pile that she is at. She'll not be jumping from one pile to another pile in the same hour. So that's the question at hand. Let's think how we can solve this question. And before we go ahead and do that, do make sure that if you want the slides for this video, fill the Google form in the comments below and then comment I want slides, and I'll share the slides with you. It'll help you quickly review these problems that we'll be discussing in this channel just before an interview. Now let's make some interesting observations, and using these observations, let's arrive at the brute force approach for solving this question. And after that, we will think about how we can arrive at the optimal approach. So these are the things that we will be doing in the next few minutes. And I have added discussion points over here for every slide so that it will become easy for you to review what we have learned and what we have discussed in this video without having to watch the video again. So let's get started. The first thing that you can observe over here is that in 1 hour, Koko will not be changing the pile. And again, we have discussed that previously. It's mentioned over here in the question. So if she chooses a particular pile in a certain hour, she has to remain with it even if she could eat more bananas than the pile has. Like for example, if there is a pile which just has 3 bananas, and if she is able, or if she chooses a speed of eating 6 bananas per hour, she'll not be moving on to the next pile after completing these 3 bananas. So that's the first thing that you need to observe. Okay, now let's think about what would be the maximum speed at which she would have to eat to ensure that she will be completing all the bananas in the h hours she has. And for that, let's make use of this example given. So we have the piles array 3, 6, 7 and 11. Okay, and the number of hours is equal to 8. The first thing that we have seen over here is that in 1 hour, she will not be changing the pile. So this means that the size of the piles array or the length of the piles array which is given has to be less than or equal to h, right? Why is that so? Let's just think of an example. Like if you have this array over here, which is the piles array. So there's just 1 banana in each pile and there are a total of 7 piles. Okay. Now, if the number of hours available is just, let's say, 5, in this case, no matter how many bananas she decides to eat per hour, she'll not be able to complete all of them, because in 1 hour she cannot change the pile, right? So again, for example, she'll be in the first hour over here, in the second hour over here, the third hour over here, and then in the fourth and fifth hours over here respectively. So she'll not be able to get to these 2 piles, and therefore she'll not be able to eat all the bananas. So therefore, because she cannot change the pile in a certain hour, if I call the length of the piles array as n, then n has to be less than or equal to h. Now, because n has to be less than or equal to h, let's try to find the maximum value or the maximum speed at which she will have to eat the bananas. And with the maximum value, I mean that definitely if she eats at that speed, she would be able to cover all the bananas in the given h hours. Again, let's take this example over here. We have 3, 6, 7 and 11, and the size of the piles array over here is 4, and that's less than or equal to 8. This is true for it, right? And again, this has to be the case because only then she would be able to complete all the bananas. Now in this scenario, notice that if she eats in 1 hour 11 bananas, which is the maximum value in the piles array which is given, so if she does that, okay, then in every hour she would definitely be completing 1 pile, and because the number of piles is less than the number of hours, less than or equal to the number of hours, therefore if she eats bananas at a rate which is the highest value in the piles array which is given to us, definitely she would be completing all the bananas in h hours. Okay, so the maximum value for k would be the maximum value in the given piles array, because if she eats at this speed, then definitely she would complete all the bananas because n has to be less than or equal to h. Again, notice if over here h is equal to 8, the value like let's keep 11 as the maximum value, and if we had 11 repeating 8 times, this is 5, then you have 6, 7 and 8. Even in this case, she would complete all the bananas if she eats 11 bananas per hour. Okay, so this is the maximum, keeping the maximum value as 11. This array over here cannot have a size greater than 8 because n has to be less than or equal to h. So what you've seen over here is that the maximum speed at which she would have to eat bananas is max of piles. Okay, the maximum value in the piles array which is given to us. So we have discussed these 2 points. Let's move on to the third point. What would be the minimum speed at which she could eat bananas if she has to complete them? And again, over here, notice it's mentioned that return the minimum integer value for k, which indicates that k can only take integer values. It cannot take fractional values. Also, if she eats, let's say 0 bananas per hour, then she would never finish it, right? Therefore, the minimum value for k has to be 1 banana per hour, because if it's 0 bananas per hour, she would not finish. And you also cannot have fractions because in the question it's mentioned return the minimum integer value for k. So far the things that we have discussed is that in 1 hour she'll not be able to change a pile. Therefore, the size of the piles array has to be less than or equal to h, which is the total number of hours available for Koko. And because of this, we have discussed that the maximum speed at which she would have to eat would be max of piles. So this would be the maximum value for k. And we have seen that the minimum possible answer, it's not that the value 1 will always be valid. Okay, she may not be able to eat all the bananas if she eats just 1 banana per hour, but the minimum value that k can take is equal to 1 and not 0, because if she eats 0 bananas per hour, she would never finish eating the bananas, and she cannot eat a fractional value because that's what is given over here. So these are the 3 points that we have discussed so far, and therefore the answer has to be a value between the min value and the max value. Or in other words, the number of bananas which Koko has to eat per hour, which is the value k or the variable k over here, is a value between 1 and max of piles. Okay, so that's the fourth observation over here, and that brings us to the brute force approach for solving this question. We know that k is a value between 1 and max of piles, so we just need to try all these values and identify the minimum possible value for k such that she's able to eat all the bananas in h hours, and that would give us the answer. Okay, so let's again see how we can do that. And the only thing remaining to discuss over here for the brute force approach is to see how to identify the number of hours required to eat the bananas given a certain value for k or given a certain speed. So let's discuss that. And again, let's take this example over here. So we have 3, 6, 7 and 11. Now if k is equal to 3, or if Koko is eating 3 bananas per hour, how many hours would it take Koko to eat all these bananas? So let's discuss that. First, let's just discuss it visually over here, and then let's see how we can convert it to code. So over here we just have 3 bananas, so Koko would just need 1 hour to complete these 3 bananas. And over here there are 6 bananas, so in 1 hour she would be completing 3, and in the second hour she would be completing 6 bananas. Okay, so it takes 2 hours to complete this pile over here, and in this pile, in the first hour she would be eating 3 bananas, in the second hour again she would be eating 3 bananas, and in the third hour she would be eating 1 banana. She cannot change a pile in an hour, so again it would take her 3 hours to complete these 7 bananas. Similarly over here for 11 she would be eating 3 and again 3, again 3. This is 9 bananas, and then she would be eating 2 bananas in the 4th hour. So it would take her a total of 4 hours to eat these 11 bananas, and that gives us a total of 4 plus 3 plus 2 plus 1, which is equal to 10 hours. Okay, so if her speed of eating bananas is 3 bananas per hour, she would need 10 hours to eat all of these bananas. So now that we have seen how this works, it's pretty straightforward to convert this to code. You would just have to take the value over here divided with the speed. Like for example over here 3 by 3 gives you 1, 6 by 3 gives you 2, 7 by 3 gives you 2, 1 by 3, right? Now in this case we want the value 3, and therefore we would have to round this up. Okay, so 7 1 by 3 becomes 3. Similarly over here 11 by 3 is equal to 3, and then you have 2 by 3. So that would be rounded up to 4. So this is how you can solve this question using the brute force approach. So let's quickly write out what we have discussed about the brute force approach. So we would have a loop where we go from 1 to max of piles, because we have seen that k will be a value between 1 and max of piles, including these 2 values. Okay, and for each value of k, you would have to find the time required to eat all the bananas, and for that you would have to loop over the piles array. So for each value over here you will be doing one loop, which is n operations, given that the size of the piles array is equal to n. Okay, and then you would just have to take the value over here divided by k and then round it up. So for each of these values you would be doing that, and then you keep adding it to the time value to get the total number of hours required to eat all the bananas given the current value of k. And then you just need to check whether k is less than or equal to h, which is the number of available hours. And if you get a valid value for k, then you can just return it, because we want the minimum possible value of k and we are going from 1 to higher values. So the first valid value of k, which is such that, and this is not k, this is time, which is such that the time is less than or equal to h. In that case we have found the speed or k at which she should be eating, such that she can eat as slow as possible and complete all the bananas with the constraints mentioned over here. And having found k, we can just return k. So this would be the brute force approach for solving this question. Okay, now what would be the time complexity for this approach? First of all, notice that we have to do one loop which goes from 1 to max of piles. Okay. Now let's say m is the value which is max of piles, or for example in this case 3, 6, 7, 11, max of piles would be 11. Okay, so let's say m is the largest value in the piles array given to us. So we have to do m operations in the worst case for the outer loop which goes from 1 to m. So this would be m operations, and then we have seen that for each of these values we'll have to do n operations because we have to iterate over the values in piles, in the piles array, which would be n operations. So that is why the time complexity of this approach, which is the brute force approach, is O of n into m, and the space complexity is just O of 1 because we are not using any auxiliary space. So we have discussed various interesting observations, and we have come up with the brute force approach for solving this question, and we have discussed the time and space complexity for the brute force approach. Next, let's try to see whether we can do better. Okay, and in this case, the key fact that gives you some idea of how you could optimize this is that the outer loop we have seen goes from 1 to max of piles, and max of piles is the maximum value in the piles array given. Okay, and again let's just take this as m. So we have seen in the brute force approach that the outer loop goes from 1 to m. Okay, and our intent is to find the value for k which would be in this range from 1 to m. It would be in the range 1 to m including both the values. Okay, so we have to identify the minimum workable speed, and we know that the minimum workable speed is in this range 1, 2, 3 etc. up to m. Okay, so let's just write that over here. So we have 1, 2, 3 etc. up to m, and in this range we have to find the minimum workable speed. And instead of just going one by one in this way and iterating over the values to find the minimum workable speed, why not use binary search to find the minimum workable speed? Because if we can do that, then notice our initial time complexity was O of n into m. Okay, and we had m over here because we had to go from 1 to m, where m is max of piles. But if we are searching for something which is ordered, and you can see the values over here are ordered, so we can use binary search, and in that case finding the minimum workable speed would not take m operations but rather just log of m operations. And that's why if we change the approach and if we use binary search, then we will be able to arrive at a time complexity of O of n into log m, which is the optimal approach for solving this question. And the space complexity still remains O of 1 or constant space. We are just going to change the way that we go over the m values over here to identify the minimum workable speed. Okay, now let's discuss this, and for this let's take this example. If this is the array which is given to us 3, 6, 7 and 11, we know that max of pile is equal to 11, and therefore the minimum workable speed has to be a value between 1 and 11. Okay, so let me just write that over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now the way that we are going to identify the minimum workable speed is by using two pointers. So I've left over here and right over here. Okay, and again this is just normal binary search. So we would start by identifying the mid value, and in this case that's 1 plus 11 by 2, which is equal to 6. So this is our mid value, and then we will try whether eating 6 bananas per hour would be sufficient for eating all the bananas. Okay, so again let's try that. So we have 3, so again to eat this pile she would take 1 hour. Then we have 6 over here, so to eat this pile of bananas again 1 hour would be required. So over here you have 7, so it would take 2 hours to complete this pile, and again over here you have 11, so it would take 2 hours to complete this pile. So the total number of hours required over here are 6. So in 6 hours, she would be able to complete eating all the bananas. And over here, notice we have 8 hours. So this indicates that possibly she could eat lower number of bananas per hour as well. Now 6 is a valid answer, but again, it could be possibly lower. Alright, so that means that we would still have to check these values over here, but because we wanted the lowest possible value and 6 is a possible value, we can eliminate all of these values. We don't need to check them any longer. That's the benefit of binary search. Okay, so if we get this 6 is a valid answer, so we would move our right pointer to mid -1. So this is where our right pointer points, and at this point k will be stored as 6. Okay, again we try to find the mid value between left and right. So that would be 1 plus 5 by 2, which is 3. So our new mid value is over here, which is 3. Okay, and then we will try to see whether eating 3 bananas per hour is sufficient or not. Now let me clean this up a little bit. Alright, so 3 is the new value that we're trying. So again, let's see how many hours would be required. So there would be 1 hour for this pile, 2 hours for this pile which has 6 bananas, 3 hours would be required for the pile which has 7 bananas, and 4 hours would be required for this pile over here which has 11 bananas. So the total over here is 10 hours. Okay, so that means that a speed of 3 bananas per hour is not sufficient because she just has 8 hours before the guards come. So that means that we can eliminate all the values lower to it, and we don't update k because this is not a valid value. So we can eliminate all of these as well. Again, if 3 is not valid, then 1 and 2 will definitely not be valid. And then we move the left pointer to mid +1. Again, this is normal binary search. So left is pointing over here at 4 and right is equal to 5. We again find the new mid, which would be 4 plus 5 by 2, and when we round it down, mid also becomes equal to 4. Okay, now let's see whether eating 4 bananas per hour is sufficient or not. So she would take 1 hour for this pile, 2 hours for this pile, 2 hours for this pile, and 3 hours for this pile. So that's a total of 8 hours. Okay, so yes, we got a valid answer. So therefore, because 4 is less than 6, we would be updating this to 4. And because this is a valid answer, we do not need to check anything to its right. Okay, so we don't need to check 5. And we had checked 6 previously, so I'm not marking it. But anything to its right, which is not already eliminated, needs not to be checked any further because we want the minimum possible value for k. And at this point, we would set right to mid -1, which is over here. And then we would just come out of the while loop because right is no longer less than or equal to left. So this is how you can solve this question using binary search. Notice that we just implemented a normal binary search for the values from 1 to 11 to find the minimum workable speed. And this is how we can solve this question in O of n log m time complexity, where m is the maximum value in the given piles array and n is the size of the piles array. Now I have one more example over here. You can try it out on your own. Like if this is the piles array and if h is equal to 2, you can just try out on your own what would be the minimum workable speed for eating all the bananas in 2 hours. Now before we go ahead and code the optimal approach, let me leave you with an interesting observation. When it comes to binary search, you can write the while loop in 2 ways. You can either have a while loop that says while left pointer less than right pointer, or you can write the while loop as while left pointer less than or equal to right pointer. Now the way that we have discussed it in this video just a few minutes ago was using this approach where we had while left less than or equal to right. Try to write it on your own using while left less than right. Now again, I'm leaving you with this. The only interesting things that you can notice over here is in this approach, when we get a value for mid which is valid, we would be updating right to mid -1. In this way, we are excluding the valid answer which is at mid. Okay, and we used explicit tracking of the answer by setting k to the answer that we got. So this is what we discussed. Now you can also do it in this way, like if you get mid as the correct answer, instead of setting right to mid minus 1, you can set right to equal to mid, and in this way you are implicitly tracking the answer at the pointer right. Again, I'm leaving you with it. I don't want this video to become too long. Now again, if you have any questions about it, do mention it in the comments below and I'll try address your questions. Okay, so again, you can write the binary search in two ways. It's good to know. You can write it with this loop, while left less than right, and you can write it with while left less than or equal to right. Let's now get into the code and implement the approach that we have discussed. So let's implement the optimal approach that we have discussed in the previous section. Okay, so we're going to use 2 pointers. Let's call it left and right, and left is going to equal the value 1 and right will be the max value in the piles array which is given to us. Okay, so you can see that's given over here, and again remember left is 1 and not 0 because 1 is the minimum speed with which Koko would have to eat bananas. Okay, and to start with, let's set k, which is what we want to return, to equal right, which is the maximum value in the piles array, because we have seen that if she eats these many bananas every hour, then definitely she will complete all the bananas, because n, which is the size of the piles array which is given to us, has to be less than or equal to h. Okay, so we have discussed that previously. So let's set initially k to equal right, and finally we will just return k. Now let's implement the binary search algorithm to identify the minimum workable speed or the minimum workable value for k, such that she would be able to eat all the bananas in h hours. So I can say while left less than or equal to right, and again remember you can write this in 2 ways. Over here I'm implementing it as left less than or equal to right. Try to write this using while left less than right on your own. Okay, so we're initially going to find the mid value, which is going to be left plus right, and then we'll divide by 2 and round it down. Okay, and initially let's say for this particular value of k, which is equal to mid, and again we have not yet assigned it to k, but we are going to test it out. So initially time is equal to 0, and let's see how many hours she would need to eat all the bananas at this value over here, whatever the value over here is. If she eats these many bananas per hour, what would be the number of hours required to eat all the bananas? So for this we'll have to loop over the values in the piles array. So I can say for pile in piles, okay, and time plus is equal to math.ceil, because you have to round up. Okay, and then we'll take every value in the piles array and divide it with mid. Okay, so this would give us the time required for eating all the bananas, and then we will check whether the time required that we are getting over here is greater than h. If this is the case, then it means that Koko has to increase her speed of eating bananas. Okay, so that means that we would not need to check all the values to the left of mid, and therefore we will set left to equal mid plus 1. Okay, on the other hand, if time is less than or equal to h, if that is the case, then we have found a valid answer. So I can set k to equal mid, and we also have to check whether we can decrease the speed. Okay, and to do that we will move our right pointer to mid minus 1, or in other words, we don't need to check anything to the right of mid. Okay, and that's it. And once we are out of this while loop, we would have identified the minimum value of k such that she is able to eat all the bananas, and we are just returning k. Let's now go ahead and run this and see if it's passing all the test cases. And yes, you can see it's working. Let's submit it, and there you have your answer. So it's working. Over here, let's implement how we would optimally solve this question in JavaScript. So we are given this function over here, and we are given the piles array, and we are also given the value of h over here. Okay, so let's have 2 pointers. So let's say left is equal to 1, because that's the minimum speed with which she would have to eat bananas to complete eating them, and let's have a value right, a pointer right, and we'll have to assign to this the maximum value in the piles array which is given to us. Okay, and again, to start with, let's say k is equal to right, because we have seen that if she eats these many bananas per hour, definitely she would complete eating all the bananas in the given time. Let's now implement the binary search part. So I can say while left less than or equal to right, and to start with we'll find the mid value. So I can say const mid is equal to math.floor, and we would be doing left plus right divided by 2. Okay, and now we are going to check how many hours would be required at this particular speed. So again, initially let me say let time is equal to 0, and then we will have to loop over the values in the piles array. So I can say for const pile of piles, so I'm taking every value in the piles array, and I can say time plus is equal to math.ceil, because we'll have to round up after taking the value from the piles array and dividing it with the speed, which in this case is equal to mid. Okay, and I would need brackets over here, so I forgot that, so let's add that. Okay, now we will check whether the time required at this particular speed is greater than h. So if this is the case, then it means that we need to increase the speed. So let's just write that over here. So she has to increase her speed, and in this case it also means that every value to the left of mid needs not be checked, because mid itself is not sufficient. We would have to increase the speed. So we will set left to equal mid plus 1. Okay, now if this is not the case, we'll check whether time is less than or equal to h, and if that is the case, then we have found a valid answer, but we will also need to check if we can decrease the speed. So there are these two things we need to do. So first let's set k is equal to mid, because we found a valid answer, and we will also set right to equal mid minus 1, because we don't need to check any value to the right of mid, because mid itself is sufficient and our aim is to find the lowest integer value for k. So we don't need to check anything to the right of mid, because of which we will set right to equal mid minus 1, and then finally we'll have to return k. So let's do that over here, and that's it. So this is how you can solve this. Now let's go ahead and run this and see if it's working. Yep, it's working. Now let's submit it, and you can see that it's passing all the test cases. If you're trying to learn data structures and algorithms through a structured step-by-step approach, do check out my best-selling DSA with Python Udemy course. In this detailed hands-on course, you will dive deep into key data structures, powerful algorithmic techniques such as backtracking, dynamic programming, greedy strategies, crucial patterns such as sliding window, two pointers, merge intervals, and solve numerous Leetcode coding challenges to sharpen your problem solving skills. Each concept is simplified with bite-sized animated lessons, relatable examples, and step-by-step coding demonstrations. By the end of this course, you will develop deep confidence to tackle DSA coding problems. To know more about this course, click on the link in the description and take your Python problem solving skills to the next level.